In this video, you will see we are starting a new chapter on polynomial functions, and this is just going to be an introduction to polynomial functions in terms of what they look like on a graph and particular parts of a polynomial expression. So please make sure you have the heading on the top of your paper. Please pause the video at any time if you need to stop it to write down something. We're going to start off these notes by doing graphs of polynomial functions. So what I've done is I've already filled in my graph, but please make sure you pause your video to fill this in. I'm going to show you three different graphs. The first one's going to look like this. So the reason why I have the graph this way is we don't need the entire coordinate grid. So I just put what I'm going to need for this graph. So if you could take the time to make an x and y axis, going from -5 to 5 on the x and -1 to -9, or to +1 on the y-axis, that would be great. So now the first one we're going to talk about are quadratics. So can you write the word quadratics on the side? What I'm going to do is I'm going to give you an example of a quadratic equation, and we're going to see what it looks like. So the first one we're going to do is y equals x squared plus 4x minus 5. We did quadratics in the last chapter, so what I'm going to do is I'm going to be lazy. I'm going to grab my calculator. And I'm only going to graph certain important features of this. So I'm going to go to y equals and type it in. So x squared plus 4x minus 5. I'm going to go to my table and center it. And what I really want to know is where it touches the x-axis and my vertex. So I'm going to plot my zeros. So we have -5, 0. And we have 1, 0. And my vertex is in the middle of my table, so that would be at -2, -9. So I'm going to go over to -2 and down to -9. Then what I'm going to do is just, if I hit my graph, I want it to look like this. It's going to be that shape, so I'm going to have a U shape. So my quadratic is going to look like a U shape. It would be upside down if there was a negative in the front. Now what I want to do on the side of it is I want to write some important information. So I'm going to put on the side here zeros, relative minimums. I'll explain what these mean. Relative minimums and relative maximums. And we'll shorten it when we go down the line. So our zeros are where it touches the x-axis. So I'm going to use a highlighter. You can choose to do the same thing. Our zeros would be on the x-axis. So it would be these two values here. So I'm just going to write my two zeros. It's at x equals -5 and x equals 1. So those are my zeros. My relative minimums would be the lowest point on the graph, kind of like a valley. So I'm going to highlight that in orange, which you don't have to. But my relative minimums, right there. And that coordinate would be -2, that point -2, -9. So I'm going to write that on the side. -2, -9. So our relative minimum would be our hill where it goes down and then up, so that lowest point. Our relative maximum, I'm going to highlight that in pink. That would be our highest point of the graph. Well, with a parabola, a quadratic, it goes on forever, so there is no relative maximum. So we're just going to write none. We're going to do this for our other two graphs. For the second graph, I'm going to have you make a graph that looks like this. The x-axis is going to go from -4 to 5, and we need our y-axis to go from -2 to 5. So at least put that down. You can pause your video if you need to. We're going to graph cubics now. Cubics mean you have a power of 3 in your equation. So we're going to write y equals x cubed minus 3x squared minus 6x plus 8. So while you're writing that, I'm going to go to my calculator, go to y equals, see what it looks like. So we have x to the third minus 3x squared minus 6x plus 8. I'm just going to see what it looks like. Here's my graph. And we can't see all of it, but notice that it goes up, down, and then up again. So there's a hill, there's a valley. So anytime we have a power of 3, this is the shape it's going to look like. So I'm going to go to my table, and I'm going to find my zeros. So I see one at -2. 0 would be when it ends in 0. I see one at -2. I see one at 1 and one at 4. So I'm going to plot my zeros. So we've got one at -2. We've got one at 1. Get one at 4. So if I was to go ahead and make that graph, very similar to this. So I'm just, for the purpose of the paper, I'm just going to take my curve. So our power of 3 will always look like this. Powers of 3 start from the bottom and go up. If it had a negative in the front, it would go down. So now we're going to label those important features of a graph. So I'm going to write zeros, relative minimums, look, I'm abbreviating now, relative minimum and relative maximums. So our zeros are where it touches the x-axis, so we have 3 of those points. So that would be at x equals, hopefully I did that right, yep, x equals -2, x equals 1, and x equals 4. Our relative minimums, I'm going to highlight that in orange, that would be my lowest valley point. So it wouldn't be down here, this goes on forever, it'd have to be a point where it's like a turning point where it turns back up. So right around here. And we just estimated where it is. So I'm just going to write C graph. So the purpose of this, I just want you to see where it is. Our relative maximum would be our valley or our hills. I'm going to highlight that. That would be about here. And I'm not going to put the specific point, but I'm just going to have you write C graph just so you know where it is. So relative mins and max have to be a turning point where the highest turning point is the lowest turning point. And you can have multiple minimums and maximums like you'll see in the next example. The last one, we're going to do quartics, which is powers of 4. So if you can go ahead and make that graph, we have an x-axis going from -4 to 5 and a y-axis going from -2 to 5. You can pause the video if you need to. So for quartics, I'll underline these. That's powers of 4. So here's an equation that it could look like. Y equals x to the 4th minus 5x squared plus 4. Kind of neat what this one looks like. So I'll go to my calculator and type that in. So we have x to the 4th minus 5x squared plus 4. If I hit my graph, you'll notice the shape. It's kind of like a W shape where it goes down, up again. So I want to figure out where my zeros are. That's where I'll start. So I'm going to go as far as I can. Let's see. So I see 4 of them, -2, -1, 1, and 2. So I'm going to go to those points and put dots. So -1 and -2, and then 1 and 2. And remember our graph looks like this. So I'm going to take my graph. Doesn't have to be perfect. We're just making a sketch. And that's the shape of my graph. So if I'm going to label on the side, we're going to label our 3 important features, our zeros, our relative minimums, and our relative maximums. So our zeros are where it touches the x-axis, so we've got 4 of them this time. So I'm going to write those 4. So we got x equals -2, x equals -1, x equals 1, and x equals 2. So those are our zeros where it touches the x-axis. Our relative minimum, those are your valleys, your turning points that are very low, and that would be right here and here. So I'm going to write 0. I'm going to write C graph just so we can look at that as we estimated. I think I might have you adjust this right here, the relative maximum. I'm going to go back to my calculator for a second. And I'm looking at my table. I just remembered that my my highest point actually touched, it was in the middle of this graph, which is on our y-axis. Well, it's got to be 0 something. So if I look at my table, I see 0, 4. So I'm going to adjust this a little bit. If you guys can do the same thing. That should have been way up there. So I'm just going to take this and curve it and get rid of that. That way, it's a little bit more accurate. So my relative maximum is going to be at 0, 4. So I'm going to highlight it, highlight this point, and just write 0, 4. For the purpose of our classwork, we're not going to have to find our minimums and maximums. I just wanted you to be comfortable with where they were. Now we're going to talk about polynomial expressions. So I'm going to go on to the next page because I've run out of room. And we're going to talk about different parts of the polynomial expression, which is what your classwork will be on. So I'll take this off. And I'm going to write parts of the polynomial expression. I'm just using my graph paper because I'm assuming you're still using it. So parts of a polynomial expression. So I'm going to give you the different parts. We're going to talk about 5 different parts. And I'm going to base that on these 2 little expressions. So on the side, can you write 3x cubed plus 2x squared minus 9x plus 7? And then the other one that we're going to look at is going to be, these are 2 separate ones, so I'm going to put a little line here. The other one's going to be 8x plus 4 minus 6x squared. So those are 2 polynomials, and we're going to talk about the different parts of this expression. So the first part we're going to talk about is a term. I'm going to give you a quick definition. Don't want us to write a lot. Our term is just a single mathematical expression. So can you just write single math expression? So each of these are terms. So 3x cubed is a term, 2x squared is a term, negative 9x is a term, and so is 7. In this expression, we've got 8x, we've got 4, and negative 6x squared. Those are our terms. The next thing I want to talk about is degree. So you can write the word degree. I'm going to try and shorten this as best as I can. The degree is just the highest exponent of the terms. So I'm going to write highest exponent of the terms. Highest exponent of the terms. So for instance, if you look at all of these terms, the highest exponent is a 3. So I'm just going to circle it and write 3 just so you know where it came from. The highest exponent here is 2. So I'm just going to circle it and write 2 just so you know where that came from. Next, leading coefficient. Leading coefficient. And pause it if I'm writing too fast. So that definition is the number attached to the term with the highest exponent. So I'm going to write number attached to letter with highest exponent. I'll say that again. Number attached to the letter. I just put 2 letter with the highest exponent. I put with highest exponent. So if you look here, our highest exponent was a 3, so our leading coefficient is a 3. So if you want to circle that and point to it, you can see where it came from. Over here, our highest exponent is 2. The number in front of it is negative 6, so our leading coefficient is negative 6. 2 more. Constant. I'm going to move this over. Probably change it up a little bit. Our constant is next. That's just a number without a variable. So the term with the number without a variable. So I'm just going to write number without a variable. Number without a variable. So for instance, if you look at all of our terms, the number without a variable would be a 7, so that would be our constant. If you look over here, the number without the variable would be a 4, so I'm going to put 4 down here. One more, that would be standard form. Standard form. We've heard of this before. Standard form. Standard form means you would write the terms in order from highest to lowest exponent. So can you just write highest to lowest exponent? Highest to lowest exponent. So if we look at this expression, it's already in standard form because the highest exponent is a 3, and then a 2, and then a 1, and then 7. So we're just going to rewrite it. So 3x cubed plus 2x squared minus 9x plus 7. That's in standard form. If you look at this expression, the highest exponent is over here, so that term goes first. So negative 6x squared goes first. The next highest exponent would be a 1, and this has an imaginary 1, so the 8x goes next, so plus 8x is positive, so plus. And then we have a number without a letter that goes last, so plus 4. That's standard form. Now I just want to do some examples that you'll see in your classwork, so I'm just going to make a quick chart. So I'm going to make, you might want to follow me first before you write this. We're going to have 1, 2, 3, 4, 5 columns. We're going to have a polynomial expression here. Need a little bit of room. We're going to have standard form over here, a little bit of room. We're going to have our degree here. Don't need a lot of room for that. Our leading coefficient. Don't need a lot of room. And then our constant will go over here. So we're going to have 5 columns. We're going to do 5 examples and then we're done. So if you want, take this and divide it into 5 spaces. Just so you get the idea, this will be like our classwork. So number 1, can you write 3x plus x squared minus 9? So standard form means highest to lowest exponent. So the highest exponent is x squared. This is a power of 1, so that comes next. So plus 3x. And then we have our number at the end, so minus 9. Our degree is the highest exponent. Well, that is our 2, so our degree is 2. Our leading coefficient is the number in front of that exponent. There's no number there, so it's an imaginary 1, so our leading coefficient is 1. Our constant is the number without the letter. That would be negative 9. Number 2. Can you write 4 plus 2x squared minus 5x cubed minus 8x? And you can pause the video if you'd like to try it on your own. All right, standard form, highest exponent is this term, negative 5x cubed. Next would be a power of 2, so plus 2x squared. Next would be this power of 1, because there's an imaginary 1 here, so minus 8x. And then this 4 goes at the end, so plus 4. Our degree is the highest exponent, that's a 3. Our leading coefficient is the number in front of that term, that's negative 5. And our constant is 4. 3 more of these. Example 3, x to the 4th plus 7x squared minus 6x cubed. And again, pause the video if you'd like to try it on your own. So highest exponent goes first, so x to the 4th. Next comes a 3, so negative 6x cubed. And next a power of 2 plus 7x squared. All right, degree is the highest exponent, so that would be a 4. Our leading coefficient is the number in front of it. Well, that's an imaginary 1. Our constant is the number without a letter. There is no number without a letter, so we're putting 0 because there could be an imaginary 0 there. Number 4, -9 plus x squared. Pause the video if you like. Standard form, highest exponent goes first, x squared. The only thing that's left is this -9, so -9. Our degree is 2 because that's the highest exponent. Our leading coefficient's the number in front of it, that's 1. And our constant's the number at the end without a letter, that would be -9. And finally, number 5, x cubed minus 5x squared plus 5x minus 1. Standard form is lowest exponent. You'll notice they're all in order. 3, 2, 1, 0. So we can just write the same to save us time. So our degree is the highest exponent. That would be our 3. Our leading coefficient's the number in the front. That would be an imaginary 1. And our constant is the number at the end, -1. So this is what your classwork will look like. Please make sure you submit a picture of this into Canvas to get credit for your notes.